Hello friends, welcome to my channel. Let's have a look at another problem related to anagram. So that is problem 567, permutation in string. This is a follow-up for problem of 438, problem 242 problem. Here we are going to use the hashing method to demonstrate one solution. First, I'll read through the problem statement, and then we look at the coding and explain the details. So, given two strings s1 and s2, return true if s2 contains a permutation of s1, or false otherwise. So, in other words, return true if one of s permutation is the substring of s2, right? So that's actually the problem. So if you check this, it's quite similar to problem 438. So here are two examples. So S1 is AB. So here we have BA, right? So BA is an anagram of S1. Therefore, we're going to return true. And for the second example, we're going to return false. In the second example, B and A did appear each once, respectively. However, so they are separated by O, but S1 has a length 2. Therefore, this should return false. The constraints on this problem are the following. First, the two strings are not empty. And secondly, their length is bounded above by 10 to the power 4. Secondly, both S1 and S2 consist of lowercase English letters. So notice that there are 26 lowercase English letters. In other words, the unique letters in S1 and S2 are naturally bounded by 26. So with that said, we're ready to look at the solution. So here I'm going to move forward fast because we just come here from problem 438. So here, first let me make a rough estimate. So here I want to check the log2 logarithm of this number. So here the purpose for this check to roughly determine how many bit positions I need to do the masking. So this actually equals 4 times logarithm 2. Logarithm 2 evaluate and 10. So this is less than 4 because 10 is less than 16, right? So we can write like this. And log 2 16 is nothing but 4. So we get 4 times 4. That is 16. In other words, 16 is strictly larger than this number. So if we want, so we can use 17 just to make sure. So the separation. So with that said, we're ready to, let me track the S1, S2 length. So this is just for convenience. And then we can introduce this cap to be 17, right? You can use a smaller number, but it's just for convenience, just for separation, sufficient separation. So here I'm going to use a hashing table like this. So character, and then we're going to use a position like this. So this is I times cap. So for I and character in enumerate. So we want to write the A, B, C, D up to Z, right? So this is nothing but the string, the ASCII lowercase. So with that said, so we are ready to do some hashing value check. So here you can understand this D as the following. So we have a very large array, and the character, let's see, A, right? We have A, so A will be take on at position I times the cap. I corresponds to 0, right? That's a 0 bit position. So if we have B, so it's going to taking on at position 1 times 17, right here. So that's the 17th index. Indexing bit position is on. So with that said, now let's look at the check. So here I'm going to have hash value for S1. So this is nothing but the character for character in S1. So because of the way we do this, so the positions of the character in S1 does not matter. So similarly, we can get a hash value reference. So that is, so here the character for character in S2, so up to this m. So here m is the length of S1, because here we are checking if S2 contains a permutation of S1. Ideally, we hope that S1 is shorter. So with that said, let's first do a check. So if the current hash value reference, let's use reference, equals the hash value of S1, so we're going to return true because we have a match. So otherwise, so we need to check for I in range, so m to n. And then essentially we are using sliding window, right? We include the ith character in the string and pop up the earliest one, that is the index at index I minus m, right? So here the hash value changes, hash value reference. So because we include the ith character, so it's going to increment this one, and then we are going to decrement, exclude this character, so S2 at I minus m, right? So then we are going to check if hash value, the reference, equals the hash value for S1. So if so, we are going to return true. Otherwise, after this for loop, and there's nothing has returned, so we're going to return false. In other words, there's no match. So with that said, I guess that's a solution to this problem. Let's first do a check. So it passes the first example. Now let's look at the generic case. Yeah, it passes all the test cases. So here, let me make a comment. So in order to use this hashing method, so this is actually in essence similar to the rubbing cap string matching algorithm. So we need to design reasonable or sound hashing, right? Here, this cap for separation is to make sure this hashing works. So here you can understand that we use this hashing value to record so which character and how many times it appears, right? So this is essentially the way. So with that said, I guess that's it. So you can think more about the encoding, right? So you can also understand this hashing as encoding. So there are some other problems in Leetcode or in our channel, so you can practice or check out. Thank you.